All right, today we're looking at 3.1, the beginning of it. We're going to be evaluating exponential functions and graphing them, recognizing their shifts and or reflections. An exponential function is when f of x equals a to the x. The variable is in the exponent. A is greater than 0. It cannot be negative. If it's negative, then it will not graph as a function. A also cannot equal 1. If a is equal to 1, then the function is always equal to 1. Let's look at evaluating some values. But before we do that, the graph, an exponential graph, can be increasing. So that's an increasing graph or a growth. We could also have a decreasing graph, which is also known as a decay. All right, so let's evaluate some. If we're evaluating this at f of 2, f of negative 2, and f of pi, we're not going to worry about f of pi. We're just going to look at f of 2 and f of negative 2. So if we do f of 2, we'll get 2 squared equal 4. F of negative 2 equals 2 to the negative 2, which is equal to 1 over 2 squared. Remember our rules of exponents. If they're negative, they go into the denominator as a positive exponent. But I want to look at one more. What happens at f of 0? 2 to the 0 power is equal to 1. Anything to the 0 power is equal to 1. All right, so now let's look at f of 1 half and evaluate it for those values. Okay, so f of 2, so that's equal to 1 squared over 2 squared, which is equal to 1/4. Let's look at f of negative 2. So that's 1 half to the negative 2, 1 to the negative 2 over 2 to the negative 2. They switch places when they're negative and become positive, so it's 2 squared over 1 squared, which is equal to 4. What about f of 0? Anything to the 0 power is equal to 1. What do you notice about the results of all these exponential functions? All the exponential functions end up being positive. Now that doesn't take into account any of the shifts that we'll have later, our h and k, or a coefficient in front of the exponential function. However, when you plug in any value for the variable as it is without adding or subtracting anything from x, you're always going to have that positive value. Let's graph a couple. We're going to do really quick, easy t-charts. Okay? The numbers that we're going to use in our t-chart will be 0 and 1. We only have to pick 2 because we are only sketching the graph. So if x is 0, it's 2 to the 0, which is 1. X is 1, it's 2 to the first, which is 2. And remember that I said that these graphs increase? Well, what did we discover when it was negative 2, it was 1/4. So will it ever cross 0? Does it equal 0? No, it never crosses that. So my asymptote, we have an asymptote at y equals 0. What about this one? We already evaluated it. Let's try x to, we'll use 0 and 1 again as our inputs. 1 half to the 0 is 1. 1 half to the first is 1 half. So we're at 0 and 1, and 1 and a half. Again, as it goes through to a positive 2, it just gets closer and closer to this, but it never crosses it. So I have an asymptote at y equal 0. Notice one graph is increasing, the top graph is increasing, and the bottom graph is decreasing. What's the difference? It's the base of an exponential. The base of this one is greater than 1. The base of this one is between 0 and 1. That tells me, gives me a hint if it's going to be an increasing or decreasing graph. All right, what about 1 or 2 to the negative x? Well, what does that mean? What does that mean? That is the same thing as 1 over, we want to make that exponent positive, so that's equal to the function 1 over 2 to the x. Let's go ahead and do our t-chart at 0 and 1. Okay, 1 over 2 to the 0, 2 to the 0 is 1, 1 divided by 1 is 1, 1 over 2 to the first is 1/2. Notice it's pretty much the same graph that we just did, and here's my asymptote at y equals 0. All right. So now let's try these two. They look very similar, except for in this one we have some h and k shifts here. But let's do 3 to the x first. We're going to use our inputs of 0 and 1. 3 to the 0 is 1. 3 to the first is 3. 0, 1, 1, 3. So here's my graph. I don't know why I started to make that dotted. And my asymptote is at y equals 0. Well, let's talk about our domain and range on this. Can I put in any value for x? Yes. So my domain can be all real numbers. My range has to be y. If I look at these values on my graph, they're all greater than 0. They don't equal 0. Let's do a t-chart for this. Let's use again 0 and 1. Okay. So 3 to the 0 plus 1 minus 2 is equal to 1. 0 plus 1 is 1. Then minus 2. Okay, now let's plug in 1. 1 plus 1 minus 2. 3 squared is 9. 9 minus 2 is 7. Okay, so my graph is at 0, 1, 1, 7. But what happens? Let me show what happens with, let's say, a negative 1. 1, let's try this again. 3 to the negative 1 plus 1 minus 2 is negative 1. So at negative 1, it's at negative 1. Well, what happened to my asymptote now? Well, my asymptote shifts down 2, like my whole graph did. Okay? So my asymptote is defined by my k value. Let's talk about the domain and range. Okay, so our domain, all real numbers. Well, my range, what's my k value? It was negative 2. It's right there. All my y's are greater than negative 2. So not only is the asymptote is the k value, It helps define the range. Helps define the range. Okay, so let's just talk about shifts now. In this case, again, we've got our H and K. So we have a coefficient. So it functions the same way as H and K. Sometimes there's a coefficient out here that will tell us some information about the graph. If we look at this one, it's going to go right 5 and up 3, my H and a K, and I'll have a horizontal asymptote at y equal 3 because it shifts up 3. This here is going to tell me it's reflected in x. It's going to go left 4 and down 6. My horizontal asymptote, y equal -6. Those are both increasing graphs. Now I look at this and I can say it's a decreasing graph because it's between the 0 and 1. It is also reflected in x. Because of the negative. There's no H shift, but it's going to shift up 5. So my horizontal asymptote will be y equal 5. This negative here tells me it's reflected in the y, so it's going to flip over your asymptote. So it'll be down here instead of, wait, not like that. Okay. Instead of this, it's going to be down here like that. It's reflected in the y. It's reflected over your asymptote. But it's still going to be shifted left 4, down 3, and have a horizontal asymptote of y equal -3. My H and K shifts. Okay, so let's do a couple here. All right, so we're going to look at this really quick. This is not a reflection in the y right here. That was a reflection in the x. Reflection in the y would flip it. Instead of this way, would flip it over and go the other direction. All right. Anyway, let's go on. Okay, so we're going to put 2 points. We're going to pick 0 and 1 again. And let's see what happens. This tells us that I'm going to have an asymptote at +3. Okay, that +3. This tells me it's going to be reflected over that asymptote. And I think I'm not going to use 0 and 1 because it's going to give me some fairly large numbers. I'll probably use 0 and -1. Why would I choose -1? I choose -1 because that makes that exponent 0, right? -2 times 4 to the -1 plus 1. 4 to the 0 is 1 times negative, this is 1, times -2 plus 3 is equal to 1. I thought that would be an easier point to choose because it makes that value easy to manipulate. Now let's try 0. -2 times 4 to the 0 plus 1 plus 3. That's equal to 4 times -2, -8, plus 3 equal to negative 5. So we're at negative 1, 1, and 0, negative 5. So let's talk about the domain. Again, I can put in any x value, but my range this time is below that asymptote, so my y is less than that positive 3. All my y values are below that asymptote. All right, let's do one more. Okay? So I'm going to look at this last one here. I look at what values would be easiest to use. First of all, let's look at our asymptote. Our asymptote is going to be at y equal 1. There's no reflection because there's no negative on the coefficient here or up here. So there's no reflection. It's just going to, this 2 will change our value. Well, again, I want this here to be 0, so I'm going to choose x equal 1. That's a nice, easy number. 2 times 3/5 to the 1 minus 1 plus 1. Well, now that's equal to 1 times 2 plus 1 equal to 3. And then I'm going to choose, let's choose 2. I think 2 is probably easier because that keeps that positive. Or I can choose 0. We'll go ahead and do 0. Well, now this makes it a little more complicated. This is to the negative power, so it's going to end up flipping plus 1. This is 10/3. Because this to the negative 1, so it changes the flip, so that's 10/3 plus 1, which is 3/3, which is 13/3, which is equal to approximately 4 1/3. So let's plot that 1, 3. And then at 0, it's 4 1/3, just about there. My domain will be all real numbers. And my range has got to be wide. They're above my asymptote, so it's greater than 1.